Halloween special, 2014, February 13th. Let's do this. Friday 31st, sir.
October 31st. Thanks, Martin. Alright, so this is going to be a quick little review of the stuff from last year for your measures of central tendency. So mean, median, and mode. And then we're going to look at quartiles and finally box and whisker plots. So, we're going to start with measures of central tendency. So measure of central tendency is just a way of looking at a set of numbers and trying to tell me what's happening on average. We use that word a lot, on average, but when we say average, we generally mean the mean of something. So your average mark, you're calculating the mean. There's other ways to look at a group of data and try and figure out what kind of overall that data is telling us. So I'm just going to show you the three mean measures of central tendency. You know them to be mean, median, and mode. And we're just going to do an example, okay, that will let us look at all three of them.
So is this your only class today?
Yes.
Oh, is that why your wife's here?
It's not my only class today. We're going up to Queenie to do the haunted house for them.
The what?
A haunted house for Queenie students.
Okay.
Okay, so this is my data set.
Central, is that it?
Central tendency, yeah. So I have 1, 1, 2, 3, 4, 4, 5, 5, 6, 6, 6, 6, 9. Alright, so those are my numbers in my data set. What they mean doesn't matter. It could be number of pets that people have. Doesn't matter. Right. Let's find the mean, median, and mode. So mean, to calculate mean, this is calculating your average. You add all your numbers. And then divide by how many numbers you have. Okay, so it's something that you guys have done probably 100 times before. So, we're going to go 1 plus 1 plus 2 plus 3 plus 4 plus 4 plus 5 plus 5 plus 6, 6, 6, 6, 9. We're going to divide that by how many numbers we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers. So if we add up all of those numbers, one plus 1 plus 2 plus 3 plus 4 plus 4 plus 5 plus 5 plus 6 plus 6 plus 6 plus 6 plus 9 equals 58 over 13, 4.46. So that would be my mean. Most often, that's what we call our average. If you find your average of your marks, you're going to add up all of your marks, divide by however many marks you have, and that will be your average. Your median, on the other hand, is the exact middle of your data and your data needs to be ordered ordered. Let me write that again. From low to high. Now I've already done that for this data set. I've already ranged them low to high. So all you're going to do for this is cross off numbers from each side one at a time. Okay? I like to do it with lines that slant opposite directions, so it's easy for me to go back and count and make sure I crossed off the same from each side. So get rid of 2 numbers, get rid of 3 numbers, 4, 5, 6. Okay, so when I cross off 6 numbers from each side, I'm left with 1 number. That number is my median. So my median is 5. The last one that's in here that we haven't talked about yet is mode. And mode is simply the number that shows up most often. Okay. And for our list, we have 6 that shows up 4 times. So in our case, the mode would equal 6. We can also look at some other things with our little data set here. We can look at something called range. And range just tells you how concentrated or spread out your values are. Okay? Your range is just the difference between your highest number and your lowest number. Okay, so range. And range is something that we're going to evaluate or we're going to expand on later. So range is the only way right now we can look at how spread out data is. The bigger your range, the bigger the number, the more spread out your data is. If your range is only 3 numbers, well then your data is all pretty clumped together. If your range is 1,000,000, well then you have pretty spread out numbers. It means your lowest number and your biggest number are separated by 1,000,000 points. That's a pretty big spread. We're going to actually quantify it better later on. We're going to do something called mean deviation. But right now, range is our best tool. So range is just high number minus low number. So for our example, it would be 9 minus 1, so it would be 8. You would say our range is 8. Ranges are tough to use on their own, but ranges are helpful if you have 2 sets of data that are the same. So if I had 2 different grade 10 math classes, and in one of them the range of marks on my test was 40, and the other the range of test marks was 10, well then I can say for sure, well my second class is less spread out. Maybe everybody is more together. People have the same skill level. It doesn't mean that they're better than my second class, because my class that has a range of 40 could have like a low mark of 60 and a high mark of 100. And the class that has a range of 10 could have a low mark of 30 and a high mark of 40. Right? So there's nothing saying that the class is better because it has a smaller range. It's just telling me how spread out the numbers are. So the people in that smaller range class are probably more at the same level, whereas the other class maybe has some people who are better and some people who are worse. Okay.
Are we about the same level, sir, in this class?
You're all pretty close.
Sure.
So you have mean, median, mode, and range. The last piece that we need to look at is quartiles, so that we could do box and whisker plots. Oops. So quartiles they divide your data into 4 groups that each contain 25% of the data. This is helpful if you want to group things. So you want to know who the lowest 25% is, the highest 25% is, and the two middle 25%. Okay. It's important that you realize that even if these quartiles are smaller groups in terms of range, they each contain the same number of people. So we'll look at what that looks like in a second. 4 equal groups, each containing 25%. So we'll do an example here. We'll calculate the quartiles, and then I'll just draw a box and whisker plot for you so you can see it. So the example can be the same as what we had before, actually, if we wanted. I don't remember what it was, so I'm just going to make up a random example now. Okay, so there's my example. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11 numbers, that's fine. Actually, you know what? I'm going to add one more. So again, what this question is doesn't really matter. It could be, again, it could be number of pets. Person with 20 probably lives at a farm. Maybe has some rabbits or something, I don't know. Okay, so the way we start with quartiles is we actually start by finding the median. Alright, so to find the median, instead of crossing them out, I'm just going to put a little symbol on top. So I'll put a little circle here to show that I've done it. So I've done 2, 3, 4, 5. Okay, so if I do 5, I'm left with 2 numbers in the middle here. Okay, so whenever we're finding, and we're lucky in this case it's the same number, but whenever we are finding median and we're stuck with 2 numbers, we just find the average of those 2 numbers. So we add them up, divide by 2. Well, 4 plus 4 is 8. 8 divided by 2 is 4. So here's Q2 right here. Falls right here. Q2. And it's 4. Okay. Now we have to find the first quartile and the third quartile. So the number that breaks it up. And what we do with that is we just separate our data into 2 pieces. So we have our first half. And we have our second half. And we're just going to find the median of those 2 halves. That's why I don't cross them out, because I don't want to lose them. So take off one, take off another. Okay, look, we're stuck with 2 numbers. So Q2, or Q1, sorry, is going to be 2 plus 3 divided by 2. It's going to be 2.5. So right away you should see something. With quartiles, your quartile points don't have to be a number that you even have. We don't have a 2.5 in our data set, but it can still be a quartile. And then we'll do the same thing with the other side. So I'll get rid of this guy, get rid of this guy, and then I'm stuck with these 2. So Q3 is going to be 7.5. Quartiles themselves aren't super useful. What they do allow us to do is build box and whisker plots. So a box and whisker plot looks like this. You're going to have a number line that has all of your numbers in it. So I'm going to build a number line, and now we can hopefully put 20 numbers in. So 1, 2, 3, 4, 5, 6, and 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Perfect. Okay, you would do this on a piece of graph paper, and each box would be a number, or each box could be 2 numbers, however you want it to do it. So now to do a box and whisker plot, you can number it. You start with a line at your first number, your lowest possible number. So we put a line at 1, because for us our lowest number is 1. Okay. Then you put another line at your Q1, which is 2.5. So that's going to go right here. And you connect those 2 lines together. Okay. Then I want you to put another line at your Q2, which in this case is 4. And you make a box between Q1 and Q2. Okay. Then I want you to put another line at Q3, which is 7.5. And you make another box between Q2 and Q3. Finally, you're going to put a line at whatever your maximum is. So for us it's 20. And you're going to connect those two lines. So that's will be what my boxing whisker plot looks like for my data. And like I said, even though each of those boxes is a different size, even though each of those boxes is a different size, they each contain 25% of my numbers. So 25% of my numbers fall between between 1 and 2.5. 25% fall between 2.5 and 4. 25% fall from 4 to 7.5, and 25% from 7.5 all the way up to 20. Okay, so you can think about these, and you can think of them as rooms. That's what I like to describe them as. This room and this room have the same number of people in them. This one's just more crowded, or in this case, we call it more concentrated. Okay. This one's more dispersed. But they each have the same number of things in them. In this case, random numbers, but they could be people or whatever. So if you think of each of your boxes as a room, that's a helpful kind of visual to keep with you. Okay? That's it for that. Go ahead.